Hey guys, thank you so much for joining us for the second episode of the webinar OWASP API Security Top 10 for APIs. My name is Inon Shkedy. I'm the head of security research here at Traceable AI, and I also the co-author and the leader of the project OWASP Top 10 for APIs. This is the second episode in the webinar. In the previous one, we talked about the background for the OWASP API security project and about the most critical API vulnerability, broken object level authorization. If you didn't have a chance to attend, you can ping us and we'll send you a record of the webinar. This is the second part of the webinar. We're going to talk about number 2 to number 5 as part of the OWASP Top 10 for API list. These are 4 very interesting and critical vulnerabilities in APIs. In part number 3, we'll talk about API 6 to API 10. And in the last episode, we will talk about how to break into APIs. This will be more like an episode from the pen tester perspective with tips how to perform pen tests for APIs. So the agenda for today is to cover 4 of the most critical API vulnerabilities. The first one is broken user authentication. Then we'll talk about excessive data exposure, lack of resources and rate limiting, and last but not least, broken function level authorization. We will see how these attacks look from the code perspective and how attackers exploit them, and including some examples from the recent time, how big companies got breached because of all the 4 of them. And I just want to mention that if you have any questions, please write them in the Q&A section, and I'll make sure to answer all of your questions at the end of the webinar. Just a quick recap from the previous episode. We talked about differences between traditional applications and modern applications, and I want to emphasize 3 points. We learned that APIs expose more entry points. APIs receive more parameters from the clients and have more endpoints if we compare them to traditional applications. Then the second point, and this is a big reason why APIs became such an attractive target for attackers, is because of the predictable nature of APIs. Today, attackers leverage this nature in order to find the admin endpoints and the more interesting stuff. And the last point is that APIs change all the time because of the phase of Agile and CI/CD. Developers change the API endpoints and add new API endpoints a few times a day. Sometimes it's even a few times every hour. And the reason why I mentioned these points, because we will see today how they impact the 4 vulnerabilities we're going to talk about. Let's jump into the first vulnerability. We're going to talk today. This is the number 2 in the OWASP Top 10 for APIs. It's called broken user authentication. So this vulnerability is basically about broken authentication mechanism or insecure authentication mechanism when it comes to authentication between users and APIs. We are not talking about authentication between microservices or between different backends. It's more about between the user itself, the client and the user, and the API. So, it's a good question to ask why authentication is such a big problem when it comes to APIs and in general, in many applications. I believe that the 2 main reasons is, first of all, if you think about it, authentication and authentication APIs is kind of like the gateway to the application. The gate is exposed to everyone by design. So if an attacker tries to manipulate your API and find vulnerabilities, the authentication APIs, in many cases, are simply the only APIs that the attacker would have access to, just because they're exposed to everyone by design. So in many cases, attackers not necessarily have access to the authenticated APIs that after the authentication, so they would just focus on these endpoints. And then one of the reasons why authentication is such a big problem today is that it's because the availability of the authentication system is crucial for the business. If you think about it, if users cannot authenticate to your APIs, it means that you can't really make money of the users because they can't use the app. This is why many companies choose to prioritize convenience over security when it comes to authentication. So I want to talk a little bit about what does it mean to have a strong and secure authentication mechanism. It's composed of two different components. The first component that you need to make sure that you have extra protection. And the second component is hardened configuration to make sure that you follow the best practices when it comes to implementation of authentication mechanisms. We're going to talk about both of them, but before we jump into it, I want to talk about what are authentication endpoints. I present about the OWASP top 10 for APIs for many companies in the Bay Area. And many times I come to a new company and I ask them, do you know what are the authentication endpoints? If the answer is immediately yes, they are probably not aware of all of their endpoints. Many companies think that authentication is only logging, but this is this is not true. In many cases, you have more types of authentication endpoints. Let's see a few examples. So if you have a feature to reset a password, or like some forgot password feature, this is also should be considered as authentication. Basically, every endpoint that has access to, that can provide you access to a user, using password, using token, it doesn't really matter, using forgot password, should be considered as authentication endpoint and have the extra protection. Other types of authentication endpoints are, for example, if you have quick access features like a magic link. Many companies send links with some tokens that if you click on the link, you would be logging to the application without providing the username and password. And another vertical you should not forget, you should also think about is old versions. So if you implemented the magic link in version 1 of your APIs and also in version 2, you shouldn't forget about the version 1 because it's probably still exposed to legacy clients. So you need to make sure that you consider this endpoint, the old version of the login or the old version of the magic link, also as an authentication endpoint. The same thing about different clients. If you have authentication for mobile and authentication for web, both of them require special protection. And last but not least, we can see today many companies would have different authentication endpoints, like in different environments. So you might have authentication endpoints in production, but also in production beta or staging or QA. And you need to make sure that you protect all of the authentication endpoints across all the environments, even if it's not production, especially if they use the same database as production. So when we talk about extra protection for APIs, extra protection basically means that the authentication endpoints, the idea is pretty simple. Authentication endpoints are much more sensitive than all of your other endpoints. So even if you have some type of rate limiting mechanism, like to your APIs, you can use some product or maybe some API gateway to provide you access control, like rate limiting and access control. It's not enough to protect the authentication endpoints. The authentication endpoint requires special protection. One of them, for example, is account lockout. This is a case where you have an attacker who is trying to brute force my own password. So he's trying to log in using the user Inon and the password of 000. And then he's trying to send more API calls in order to brute force the password. But after 3 attempts, the API should lock the user. So the attacker can just keep guessing the password. But this is also kind of a tricky mechanism because if the attacker found that the user is locked after 3 attempts, he can basically write a script to lock all the users on the app and to try to guess wrong passwords for all the usernames on the app. And then it's some type of denial of service to the app. So also here, you need to design very carefully your authentication mechanism and the protection on top of it. When we talk about brute force mitigation, there are different ways to block attackers that are trying to perform a brute force of passwords to your API. The first approach, which is the most common, is based on IP address. If we saw that one IP address has access to the login endpoint more than 10 times, in most of the cases, there is no reason not to block this IP address. You should do it. The second approach is based on the geolocation, and the last one is based on the device ID. So it's very common in mobile applications like iOS and Android that you have the device ID, and then you can block, like if you see that one device is sending too many calls for the login endpoint or the authentication endpoint, you should block this device ID. One thing that we can see that companies prefer to do today, instead of blocking based on IP address or device ID, instead of blocking in general, they just send back a CAPTCHA to the user. It was a bit easier to integrate CAPTCHA when it comes to traditional applications because you could just inject HTML, but because APIs don't send HTML, you can't really use the same approach. And it requires, in many cases, when you want to implement CAPTCHA, it requires some client-side changes. But if your business logic requires it, it's worth it. The second type of family, the second family of problems when it comes to authentication is hardened configuration. You need to make sure that you follow the best practices when it comes to how to implement authentication mechanism. And the best tip I can give you, never try to implement authentication mechanism yourself. You should use solutions like open source solutions that already exist in the market in order to implement authentication mechanism, because usually they contain less vulnerabilities. And about configuration, there are many things you can do to make your authentication mechanism more secure. One example is you should expire tokens. If you have tokens that never expire, this is a bad thing. Or the configuration of JAW tokens. Some authentication mechanisms allow the algorithm in the JAW token to be none, and basically means that the attacker can change the user ID and it's full account takeover. So if your authentication mechanism supports this algorithm, it's very dangerous. Another point is weak encryption algorithm, and you have many more things. And if you want to make sure that you secure your authentication mechanism, I would highly recommend you to follow the OWASP guidelines when it comes to authentication. There is the OWASP authentication cheat sheet. You can take a look at this cheat sheet and to find all the best practices. And there are many things that you can do. Like if I wanted to talk about all of them, it would be a presentation of probably 5 hours. I want to talk about one example when it comes to broken user authentication. It's a pretty cool example that the security researcher Inon Shkedy from AppSecure found on the Facebook API. So what Inon found is that there is a feature on Facebook that allows you to reset the user password based if you provide your phone number. So the process was, first you provide the phone number of the user that you want to log into, and then the API would send you an SMS token with an SMS with a token, and the token was only 5 digits, like 5 digits. And then the third step would be, from your perspective, to send this 5 digits token to the API. And if you send the right token, you would have the option to reset the password of the user. So Inon saw this mechanism, and he said to himself, okay, 5 digits, it sounds pretty easy to enumerate. There are only 100,000 options. So he wrote a script to enumerate all the options for the token on facebook.com, but he got blocked after 10 attempts. Inon didn't give up, and it tried to, and then it started looking for subdomains of Facebook, and he found these 2 interesting subdomains, beta.facebook.com and mbasic.beta.facebook.com. Those 2 APIs use the same database behind the scenes. So it's basically production data, including the username and passwords of the users in production. But the interesting part is that these APIs did not implement rate limiting. So they didn't block the client after 10 attempts, like facebook.com. This way, Inon managed to basically perform full account takeover. He could take full control on every account on Facebook just by guessing this 5 digits code and reset the password of the user. Let's jump into API 3. This is the second vulnerability we are going to talk about today, excessive data exposure. This is one of my favorite vulnerabilities. You know why? Because as a pen tester, instead of like performing complex pen tests that you need to understand the business logic and to send malicious payloads, you just take a look at the traffic and API and see that APIs leak PII of other users by design. It's very easy to exploit excessive data exposure because there is no exploit. You just take a look at the traffic. It's kind of an interesting situation. The developers return PII of other users by design. Let's see how it looks like behind the scenes. So let's say that you use some dating app. It's very common in San Francisco. And then you see this guy on the dating app, Bob. And you can see all the public details about Bob, like the name, the profile picture, and the hobbies. You should be able to see all these details because they're public, it's fine. But if you take a look behind the scenes at the traffic between the client and the API, you'd see the following thing. There is an API call from the client to the API, get/user/717, which is the ID of Bob. Then the API response contains all the public details like the name, hobbies, and profile picture, which is fine. But if you take a look, the API actually returns also the address of Bob, which is PII. This is private information that shouldn't be exposed to other users. So what happens here is that the developer on the backend, they rely on the developers on the front end to filter out this sensitive data. And they actually do it because you can't really see it here on the screen. But as an attacker, you can easily sniff the traffic, intercept the traffic between the client and the API, and to see all this sensitive information. So just to emphasize, filtering sensitive information on the client side is always a bad idea. A good question to ask is, why does it happen? Why developers like just return PII of other users? It's a good question. It took me some time to understand why. I believe the main reasons are, first of all, APIs are very generic. If you think about it, one API endpoint might be consumed by multiple clients and multiple features on the same client. So developers tend to create much more generic endpoints so they can be reused in many different clients, which is very convenient, but many times it comes with the price of exposing the whole object. So developers would just use the two JSON or two string functions from the ORM or the model in order to get the full JSON object of the, the full raw object of the resource, and without filtering out the sensitive information. And many times developers don't really have the context of the access control policies. So for example, if a developer gets a task to implement an endpoint to return some resource, many times he doesn't have the context of who is the consumer of the data. This is something very important that many times doesn't happen. Developers will just implement a specific endpoint without having the full context. One example for this vulnerability, it was found by Alex Lomas from Pentest Partners. It was on an app that's called 3Fun app. Basically an app that allows couples to find other people that are willing to join them. Basically an app for swingers. And Alex found something very interesting. When you use the app, it shows you all the users around you. And behind the scenes, there is an API call to get/match users, and then it returns you a list of all the users in your area, which is fine because this is part of business logic. But if you take a look at the API response, you can see private information about the users around you, including private photos. And more interesting than that, you can see their exact location. So the next thing Alex did is to write a script to enumerate all the users who use the 3Fun app around the White House, which is very interesting to see the results, to see that they're pretty active over there. Let's jump into API number 4, lack of resources and rate limiting. So basically, this is a vulnerability that might lead to denial of service. That the API doesn't perform rate limiting. And it becomes more and more common and severe in APIs. And I want to talk about like why. Why is it more common in APIs? So as we talked in the first episode, back in the day, it was common to see that the server would maintain the user state. The server would know exactly what buttons have been clicked by the user, even where is the location of the mouse of the user. and it was supported by mechanisms like view state and cookies. But today, the approach when it comes to APIs and modern applications, it's very different. Today, it's the responsibility of the client itself to maintain the user state. So the server have much less context. But in order to, in some cases, for example, if you want to look for a specific, if you want to search for something, or if you want to navigate between pages in the app, the client needs to reflect the user state back to the backend. So it leads to a situation that because clients maintain the user state, there are more parameters sent from the client. And many times these parameters are used for filtering. And if you have the option to control the filter that would run on the backend, you can do malicious things. For example, in this case, you have these social network APIs, and you have an endpoint to expose the users list, and then you have the limit field. And usually users would send between 1 to 100, but then you send a very long value of more than 1 billion. And this might lead to denial of service because the API would try to fetch too many resources. Let's talk about API number 5, broken function level authorization, or BAFLA. This vulnerability is kind of the sister vulnerability of BOLA, which is the first vulnerability in the list. So in the case of BOLA, we're talking about object level authorization, but in the case of BAFLA, we talk about function level authorization. Let's see how it looks like. So let's say that you have an API that exposes 3 different sub APIs. One of them is for admins, one of them is for riders, and one of them is for drivers. And then you have an admin that is accessing the function of delete/user/717, which is fine because admins should have access to access this function, right? But what happens if an attacker that has like a guest user or just a normal rider user in the API would access the same exact API endpoint? So in many cases, the developers in the backend don't really validate that the user or the client belongs to the admin group. And then they would allow the attacker to access this sensitive admin endpoint. And in this case, that the attacker can simply delete all the users on the app. I just want to emphasize here, it's not about a broken object level authorization, because the problem here is not the ID. The problem here is the attacker can access the delete function. It should be accessed only by admins. It's much easier to detect BAFLA in APIs. It's not a new vulnerability, but it's much easier to detect it in APIs. In the case of traditional applications, in order to access the admin function, if you take a look here on the right side of the table, you can see that it would look very messy, like post/admin/admin panel/user management of the SPX, and then we need to mention the delete, the action equals delete, and the user ID. It would be hard for you as a pen tester to guess this entry point. It's not very predictable. Hopefully, fortunately, in APIs, it's very easy to find these admin endpoints in many cases. Because if you have an API endpoint that you just see that you should have access to as a regular user, which is get user profile, if you just change the HTTP method from get to delete, you might find the admin endpoint to delete the user. Because REST APIs are more predictable, it's much easier for you as a pen tester to find admin endpoints. There are many ways to implement this function level authorization, and this is what makes it more hard to follow the best practices and to make like the function level authorization secure. You can do it in the code level, in the configuration level, and sometimes even in the API gateway. And also in admin, like today in APIs, you have complex groups or complex roles. You might have admins, super admins, supervisors. It makes it more challenging to create decent policies to cover against these attacks. One example for a broken function level authorization, it was found on Shopify by the researcher UZ Sunny. It allowed an attacker to access an admin endpoint and to assign himself as a collaborator to access any store on Shopify. Basically, the attacker could create himself a collaborator account on every store on Shopify and to get full access to the shop, including changing the inventory and full access to the user payment information and so on. And the problem was that the API did not validate that that the user was access to this special admin endpoints using an admin account. So this is the presentation for today. We talked about 5 of the vulnerabilities. In the next meeting, in the next episode, we're going to talk about API 5 to API 10. I also invite you, you should join us next week to the next webinar. It's the CSU Panel at 10 a.m. PST. And we are going to host many people from the industry that are going to talk about API security. Now it's time to questions.
Thank you, Inon. We have a couple of questions from the folks in the audience here. And I encourage you to write your questions in the Q&A window. And you can ask not just about today's content, but if you had some questions about IDOR or BOLA or anything about the previous episode, feel free to ask as well. So Nihal is asking, what hashing algorithms would you recommend for protecting passwords?
Yeah, it's a good question, and I would recommend you to use a SHA-1 for hash password. You can also use a bcrypt. It's a new trend today.
Thank you. Another question here. If you have an anonymous attack, especially if it's coming from a known anonymous network like Tor, what are the typical attacks there, and how you can protect against them? Perhaps on the network layer.
Yeah, so if you have attackers that you see from Tor or from botnets, many times it's not necessarily API attacks. It's more about in the field of denial of service. And the right way to protect against this type of attacks is, first of all, to make sure that you update all of your operating systems, because many times those attacks that are trying to perform denial of service would leverage some like vulnerability in the operating system. And you can also use solutions to rate limit to rate limit the API calls or just traffic from Tor endpoints. In many cases, I see companies that just decide to block all the Tor endpoints by design, just to block all the IP addresses from these networks.
Great. Another question here. You have mentioned BOLA in the previous episode. Is it just the REST APIs that are vulnerable to that, or are there other types of APIs that are also vulnerable to BOLA?
Yeah, it's a great question. And the reality is BOLA is not a new vulnerability. We just decided to give it a new name. You could find BOLA in traditional applications, in REST APIs, but the reality is that every API, including GraphQL, gRPC, basically every entry point that you have to your servers, every time you can, even like RPC might be vulnerable to BOLA. Every type of API and communication might be vulnerable to BOLA, as long as there are IDs that are sent from the clients, it happens in most of the cases.
Great, thank you for that. Another question coming in, if you have people who are known pwned, things that have been known to have leaked, can you stop logging from these people?
Sorry, I'm not sure if I got the question.
If there are known compromised accounts, are there tools that can help you by stopping those users from logging in?
Yeah, I think there's some tools in the market. I'm personally not super familiar with these technologies. But yeah, you have databases that one of them is Have I Been Pwned, that they expose the list of users that that have been compromised. So there are some solutions that leverage these databases in order to block authentication attempts to these users. But you also need to remember that if you implement this type of solution, you might also block access to the real users that got compromised.
From my side, I can also recommend that people use Traceable here, because we do provide a user-level protection and monitoring for specific malicious activity on a user basis. Another question coming in, do you have any recommendations for managing complex authorizations? Specifically, they're looking for an open source tool or a solution that can be used to manage authorization that way. Not sure if this is meant to be in a generic environment or perhaps more specific in a microservices way.
Yeah, it's a good question. And to be honest, authorization is such a broad concept. You can have authorization when it comes to the cloud provider, the way that you access your cloud, the AWS console. This is one type of authorization. So we need to understand what type of authorization we are talking about. If we talk about the authorization that you implement in the application that you develop, it depends on the framework. So for example, in the case of Ruby on Rails, you have the framework of can that allows you to set complex authorization policies. If you send me, you can ping me on LinkedIn or Twitter and to send me the type of framework that you use, and I'll send you the best practices and the recommended frameworks to this, the recommended authorization frameworks to this specific programming language or framework. But it's a very good idea to use solutions like open source solutions and not to implement everything from scratch. Even though in some cases, many times companies need to extend these frameworks in order to support their business logic. And this is many times where companies and developers make mistakes when it comes to authorization. So you need to make sure that you review all of the extensions for the authorization mechanism that you make.
One more question coming in here. Since you have experience as a pen tester, are there any information sources, books, or the like that you could recommend for API penetration testing? And just a reminder, guys, the last episode of the series will focus exactly on that. So Inon will share his own personal tips on API penetration testing. But Inon, any books or anything like websites?
Yeah, I think there are a couple of courses on Udemy. I haven't tried them, but I think most of them cost money. On top of that, you can follow me on Twitter. A few months ago, I published 31 tips for API pen testing. And I also, every few days, I publish new tips about API security. And I also can give you, if you ping me on Twitter, I can give you names of accounts to follow on Twitter to get more information about API security. Oh, and there is also APIsecurity.io. It's another good source for to read about recent breaches in API security.
All right. Well, that's it for today. Thank you, everybody. I hope you or your colleagues can join us next week. We will have a number of distinguished CISOs talk about API and application security from a practical and organizational standpoint. And then, of course, we will also continue this series with 2 more episodes that Inon has talked about. So we hope to hear and see you again in our upcoming events.
Thank you, guys.
The recording of this webinar will be available on the same page where we've published the first episode. So if you missed it, or if you want to share it with your colleagues, also feel free to do that.
Okay. Thank you, Renata. Thank you, guys. Bye-bye.